Hello, this is Dr. Chung. This is part 3, 2023, okay, June Regent test. Okay, before we start, I forgot something, right? When you review part 2 over here. Where is it over here? Construct, right? Where is it? Oh, here, right? Okay. Last time we did this one, that is counterclockwise 90 degree, but you have to say the center, right? Okay, I forgot to say the center. At center, 0 and 0, okay? All right. Okay, move on. Part 3 today. This is part 3, the first one. Okay, you can read over here, right? The rocket over here, okay, from. So we have observer at point A, and that is elevation angles. Okay, the first observer is rocket is at point C, and second times rocket is at point D. At this time, elevation angle is at 31 degree. Okay, yeah, that is the question, I think. Okay, determine a state nearest to distance the rocket traveled between the two siding C and D. Okay, yeah, this one. We're gonna find the distance C and D. Okay, make a little big. That is better. Okay, how can you find the lengths of C and D? First, using this one because this horizontal distance is given. Okay, and using the tangent of these two angles, we can find the opposite side. So dB equals how much? Using 31 degree, right? So 320 times tangent 31 degree. We know that tangent 31 equals for opposite dB over adjacent 3280, right? So dB equals what? 3280 times tangent 31, right? Okay. Another one, same thing. Tangent 15 equals what? CBC, right? Yeah. So this side is a BC. That is equals same thing. 320 times, and tangent, I'm going to compute right that this is better. And tangent 50 degree, right? That is the length of BC. So x is what? Difference of these two, right? X is what? dB minus BC, right? So 3280 times tangent 31 degree minus 3280 times tangent 15 degree, okay? Or you can use this one too to render it. 3280 is common factor, right? So minus tangent 31 degree and minus tangent 15 degree, okay? You can use this one too. So I'm going to use the internet calculator, okay? Nearest put, okay? The first one over here, 3280 times tangent 31, okay? Tangent 31 and the minus tangent 15, okay? Tangent 15. So you got the number here. 1358, the next number is 8. Okay, one up over here, 1359, okay? 1359 feet. Don't forget the right, the unit. Okay, that's the answer, okay? Okay, move on next one. A small can of soup is a right circular cylinder. The base is 7. This is the right circular cylinder, right? Diameter over here 7, and height is 9 centimeter. That's the cylinder, right? A larger container also right circular, okay, diameter is 9, a little large one, height is 30, a little large, a little large. Diameter is 13 centimeter, and height is 9, no, height is 13, right? Diameter, this is 9 centimeter, height is 13 centimeter, okay? Okay, determines the volume of small can and the volume of large can to the nearest cubic centimeter, okay? What is the volume of this first one? This volume, I'm going to do the small one, V1. Pi r square, right? Base times height. Pi r square. R is half of this one, okay? So 3.5. And times 9, okay? Because you know that pi r squared times h. This is the base, right? Okay. And the second one is pi times 9, half is what? Radius. Don't forget that, okay? You need to divide by 2. 4.5 n squared times 13. All right? So using this one, we're going to find first up here. Pi times and the 3.5 squared and times 9. So nearest cubic, right? 346.3. So discard the next number, 346, okay? 346 cubic centimeter, okay? Don't forget unit. The second one over here. 5 times, I'm going to do this one, 4.5, right? This is a 4.5. And times 13. I'm going to change this one, 13. 827, right? Okay. 827 cubic centimeter, right? That's the value. Okay, what is the minimum number of small cans that must be opened to fill largest one? Okay, okay. Divide, right? 827 over 346. Okay, use this one. 827 over 346. 2.3, right? 2.39, something like that. Okay. So the number of cans is integer, right? It can be decimal. So 2 is just a little short, right? You're gonna make what? 3 cans, okay? That's this. The next number 34, parallelogram MATH. I'm gonna do parallelogram in general, right? We don't need to write a graph paper. So M is negative 7 and negative 2. A is 0 and 4, right? T is 9 and 2. And H equals 2 and negative 4, okay? To prove, right, the parallelogram is rhombus. If you parallelogram, you can add additional one more factor of it, right, to prove it's rhombus. What is this? You can use adjacent side congruent. Congruent, adjacent side. Right? Only one pair, that's enough. The other one is parallelogram and diagonals perpendicular, right? Perpendicular diagonals. This is also what? Rhombus. I'm going to go this way. Adjacent side, congruent. Because what? Rhombus has all congruent side. Okay, this is parallelogram. All congruent side is what? Only one. This is parallelogram, all congruent side. Okay, it's only rhombus. Okay. So now let's find distance from MA, okay? ma equals square root x2 minus x1, 0 minus 7 is what? 0 minus 7 square plus 4 and minus 2 square, okay? This equals to 7 square is 49. This is 6 square is 36. That is equals to square root 85. Second one is, I'm going to mh, that is adjacent, okay? mh. You can the other side of 80 is okay too. x2 minus x1, 2 minus 7. And the negative 4 and minus 2. Okay, x2 minus x1. This is 9 squared is 81, right? And this one is a negative 2, right? Negative 2 squared is 4. Square root 85. Okay, so MA equals to MH. So you can explain, right? This way. If parallelogram has congruent adjacent side, okay? That's simple. Okay? The parallelogram with congruent adjacent side. Rhombus. Okay? Or you can use this one too, diagonal. At this time, this is why we're gonna find the slope of this one and the other slope of this one. They must be what? Perpendicular. Alright? Okay, the next one, determine and state the area of this parallelogram, right, which is the rhombus. Okay, at this times, we better use diagonal because we know that these two diagonals are perpendicular, right? So look at this. This is MATH. Now let's find the length of this diagonal, AH. AH equals to still, you're gonna use distance formula, right? 9 minus 7 n square. 2 minus 2 n square. That is equals to how much? That is 16 square, right? And plus 2 minus 2, 4 square, 16. That is 256. You have to use a calculator, okay? 256 plus 16 equals square root 272, right? The next one. MT. The perpendicular. MT equals we did write this AH for 9 minus 7. Well, this is the MT, right? This is MT. This is AH, okay. 2 minus 0. Plus 4 minus 4 square. That is equals to 2 square is 4. And this is the 8 square is 64, right? That is equals to square root 68. Okay? Alright. What is the area of this one? Diagonal times diagonal and divide by 2, right? So area equals diagonal. Square root 272 times square root 68 over 2, right? Because when you area of this one, when you multiply these numbers, area of this one, right? But this area of rhombus, half of that area of this rectangle, okay? That's why we need to divide by 2. You can use decimals to find this one. The square root 272 times square root 68. After that, divide by 2, right? 68. That equals to 68. Where is the unit? There's no unit, right? This is just right. 68 square unit. You can say square unit. Okay? That's the answer. Oh, when you write graph of this parallelogram, it gives you some idea, right? This one looks like a rhombus. I'm going to show you. -7 and -2. -7 and -2 here. And 0 and 4 over here. And 9 and 2 over here. And 2 and -4. 2 and -4 over here, right? So then you make the line. Oops. Okay. When you make that diagonals, that must be perpendicular, right? Okay. All right, the next one. Okay. Oh, this is the last questions. Okay. So I can see the next video, right? Okay. So we're gonna continue part 4 here, right? Okay. Okay. I'll see you next video. Thank you.